This is the Brocade Campus Feature Explainer Series. I'm Terry Henry. In this episode, we're going to talk about Ospf link cost and reference bandwidth. So what I've already configured here is if we do a show IP Ospf neighbor, I have two links going to the same neighbor. So VE1, VE2 on two different subnets, 192.168.1.56 and 2.56. They're both in full state. The other side is DR, and I'm connected to the same neighbor, right? So if I look at my routing table is showing me two different routes, right? So 2.2.2.2/32. So this is the loopback on the remote side. It's showing me two different paths, right? So equal cost multipath is turned on by default for up to 4 links, and so it is treating those equally, and it's going to load balance among them, which is great. The downside here is that because Ospf is so old, the reference bandwidth for Ospf is 100 megabit. So anything faster, 100 megabit and faster, so 100 megabit, 10 gig, 40 gig, 100 gig, etc., is all considered the same speed according to Ospf until you change the reference bandwidth. So in this particular case, let's see, it's 1/1/E1/1/1 and E1/2/3. So here's our two links that our neighbors are on. They're both up in forwarding. The trouble is one of them is a 1 gig link and the other one is a 10 gig link. So this is not what we want to happen. We do not want equal cost multipath to send an equal amount of traffic down both those links. What I want to do is change the reference bandwidth so only the 10 gig link gets put in the table, and in the event that the 10 gig link goes down, we want the 1 gig link to take over. However, what we don't want to do is send an equal amount of traffic down both of these links, so the 1 gig link will get overwhelmed and never be able to utilize all the potential here. So the way we do that, config T, we're going to go into router Ospf, and so the reference bandwidth by default is 100 or 100 megabit, right? So what you want to do is set your reference bandwidth on all of the routers in your area to at least as fast as the fastest interface. So a gig would be 1,000, 10 gig would be 10,000, 100 gig would be 100,000, etc. So the command to do that, it's auto-cost and reference-bandwidth. And then we set it to a number. So this is going to be the numerator, and the link speed is the denominator. So it's reference bandwidth over link speed. So if we set this to 10,000, for example, a 10 gig link is also 10,000. So it would come out with a cost of 1, right? So we're going to set it to better than that, though. We're going to set it to 100,000. Because we're assuming someday we make it to 100 gig interfaces somewhere in this area, and we don't want to have to go in and reconfigure the reference bandwidth on all the routers again. So we'll set that to the reference bandwidth to 100,000. So that should give me more than plenty. But what we need to do as a best practice is to go in and set that reference bandwidth on all the routers, because if you don't, each router will calculate its cost differently, and you could run into some issues. So anyway, so we set that reference bandwidth, and so right away that should take effect. And if I do a show IP route again, oops, I now have only one route to each one of those, where I used to have two in the equal cost scenario, and they're both via VE1 or the 10 gig link. So if I had multiple 10 gig links, it would have been fine, but I would still, you always want to set that reference bandwidth. Okay, that's it for today.